Today's session, we would be starting with SQL, how to write or how to start with the basic queries, how queries are written, how the information is processed in any SQL databases. So that we are going to start with. I mean, just to rewind back, because we discussed something related to database, related to the components present in that database. So we will go back for the Friday session, which we discussed. So on Friday, what we discussed, we'll go back to that and just to get an idea how the database works. So all these components will again kind of rewind it, right? So that it's very easy to understand. Okay. Okay. Now we started with a basic example. What exactly a database is, rather what exactly what all components are present in that specific database, right? So database is at the highest level of hierarchy. Now we would correlate what example we have taken with respect to these databases, right? Now we had taken an example of Superstore, right? So there is a Superstore or there is a maybe any Mart where you're trying to purchase certain set of products. So if I try to take, we have taken an example of DMart. So DMart is nothing but your complete database. So inside this DMart, uh, you're trying to purchase certain products, right? So you visit that designated area, so where all that specific products are kept. So how that products are kept, they are kept in terms of racks. So these racks, you can call it as a tables, right? So this is what the tables is. Now I'll do it vice versa. Table is under database. So what all these tables are, these are racks in a specific superstore or a supermarket. We're trying to purchase certain product. Now, after these racks, how the information is kept in these racks, the information is either kept in rows, which are also called as tuples in database terminologies, which are also called as tuples. So rows is what the information is from left to right. Now, I could have said it vertically, I could have said it horizontally, but see, people get confused what is vertical, what is horizontal. So I'm trying to keep it as simple as that. One which goes from left to right is your row, and the information is also kept in columns, which is also called as fields, right? So fields is nothing but from top to bottom, either from top to bottom or bottom to top, but anyways, it is from top to bottom. Now, once these columns are tables, once a table is created, the information is stored in rows and columns. Table is part of a database. So this is what the primary discussion we have done. But along with that, we have also discussed what do you mean by schema. So there are two different schemas, right? We discussed physical. Now, physical is what? Physical is nothing but where do you want to create that specific table inside a database, right? Schemas in database, right? So where do you want to create a table or where do you want to rather create a database? So where to create the place, the place at which we want to create. And there is one more schema which is called as logical schema. Now, what do you mean by logical schema? Logical schema is nothing but where and how we want to create. Rather, where is what physical, but how we want to create. What should be the structure? What should be the structure? So it would be structure and its components. Now, how many rows, how many columns would be there? So all that would be mentioned inside this logical schema. So we have also discussed schema, and we have discussed two ways of processing the database. How you mention, how you insert that information, how you manage that information also we've discussed. So ways of processing the database or data in a database, rather data in database. So we have discussed two ways. One is OLTP, which is frequent updates. right? So the data which is getting frequently updated is called as OLTP, and we have also discussed OLAP, which is rarely updates. So we have gone through all these components. Now the question comes, along with these components, see, I mean, we have taken an example of DMart. So if you visit any specific superstore and you feel that the product which I'm trying to purchase, that specific product is not available, so you usually visit a person, I mean, who is part of that superstore only, right? You cannot ask any other person, maybe a person who's standing next to you. He's not a part of that superstore team, but you cannot ask him that I'm trying to purchase this product. This product is not available. You usually visit a store where if you're not finding any product, you connect with the person who is part of that store, either the store manager or either the person, maybe the owner of that store or the person who is managing that store. So similarly, if you want to create a database, if you want to ideally manage that database, that management is also a part of database, right? So whenever you're trying to manage a database, whenever you're trying to manage all the tables in that database, that process is called as a database management system. There is a component called as database management system. Now, what do you mean by database management system? Person who manages all these components, who is ideally maintaining all these components, who is also acting on these components, is called as a database management system, right? So you try to take any specific example, right? Maybe you're visiting a movie, right? You're visiting a multiplex. You want to watch a movie, so you're not sure. Maybe once where is the exact screen located? I mean, where is my seat located? Maybe seat numbers are mentioned, they're accepted, but if the seat numbers are not clearly visible, you usually ask a person who is managing that movie theater, right? You, the person who is managing that multiplex. So the person who is managing that multiplex might be a manager, might be owner of that multiplex, or a person who is dedicated to the helping people who is visiting that multiplex. So similarly, a person who is trying to manage this database is called as a database management system. And that person, maybe you can call it as a developer, that person you can call it as a tester also. Maybe a person is also trying to test that specific database, whether it is working or not. So all these components come under one single application, which is called as database management system, where all the management happens, where all the processing of information and ideally maintaining this information happens. Now, in simple terms, database management system is classified into further three more types, right? How do you manage? Rules and regulations are there, right? How do you manage a movie theater? How do you manage a superstore? So similarly, how we manage a database management system, there are three types. There are three different types. Now, what all these three types are, we'll go through all these three types. Just a moment. Hmm. Okay. Now, see, a person who is that a database management system for storing, retrieving all the user information. I mean, the person who is managing all these databases is called as database management system person. Now, as I've said, DBMS has three different architectures or three different types rather. Now, type one is tier one architecture. Type 2 is tier 2 architecture and type 3 is tier 3. Now, why am I going all through these is because you can understand the basics of database, how management happens, only when you can directly jump to that specific database and easily write managing the queries, right? If you directly jump to write the queries, it is very difficult to understand. And you might also expect a person who is 1 year of experience, you might also expect these kind of questions in the interview. What is OLTP? What is OLAP? What is DBMS? How a DBMS works? What is the architecture behind it? So even you might expect some questions with a person of 1 year or 2 years of experience. Usually these kind of questions are asked, right? Now, as I've said, there are three different types, tier 1, tier 2, tier 3. Let's not confuse with all three types. Forget about tier 1 and tier 2. because these two architectures or these two DBMS styles are not used nowadays, that are outdated. Now, only tier 3 architecture is used. Now, what do you mean by tier 3 architecture? I mean, ideally, DBMS is management of your database, but how you are managing is what we want to discuss in this three types of options which we have. So the third option is tier 3. This tier 3 option, tier 3 DBMS, is called as a client server architecture. It is called as a client server architecture. Now, what do you mean by client server architecture? In simple terms, just a moment. Yeah. Okay. Now let's assume this as a database, right? This is your database, or you can assume this as a superstore. A complete superstore is there. So inside this databases, there are multiple tables, right? These are all your tables. Or you can call in every superstore, these are all your different sections where all the items, all your products are kept in separate racks. So these are different tables. This is table 1, table 2, table 3, all these information is kept. Now, for every table, we have a row and we have a column, right? This is your row, which starts from left to right, and this is your column, which starts from top to bottom. Now, one who is managing this, how he will manage that if a certain person is coming with a complaint. Now, what that person would be who's trying to purchase a product from that superstore. So that person, we can call it as a client. A client is the one who is visiting the superstore, is trying to purchase a product. Now he visits this table 2, which is rack 2. So once he visits this table 2, he wants a product which is not available here. Maybe that product is out of stock. Out of stock in the sense that product is not available in that rack or in that table. Now what he will do, he will connect with the person who is managing that superstore. It might be a manager or a person who is managing that superstore. So what this person will do, a command is given from client to a person who is managing. This person will go back to the warehouse in the background. From that warehouse, he will check whether that product is available in the warehouse. If that product is available, he will get that product and he'll place that product in this table 2 or the rack 2. So there is a way of communication, right? From a client to a person. From that person, he will go back to that warehouse. From that warehouse, he will pick up that product and he'll place that product in that specific table or designated area. So the DBMS is what? It is about management of all these components. A person who is managing the superstore, you can call it as a DBMS person, right? So what that person is doing, he's getting some idea, he's getting some information, he's getting some request from that client. What that request is, a product he's trying to purchase. Maybe he's trying to purchase a biscuit. So that biscuit is not available. So he will go back to that warehouse, get that biscuit and place that biscuit in that table 2. So this information is called as a 3-tier architecture. Now how 3-tier works is, client will request, it will go to a specific person. Now in database, there is no person. In database, there is a server. Server will act like a person. So a client will request, it will go to server. From that server, it will check whether what information is requested from that client is available or not. If it is available, it will give you the output. If it is also not available, it will give you output that information which you are requesting, it is not available. So this information is called as a 3-tier architecture, client server architecture rather. So how this 3-tier architecture look alike? 3-tier architecture look like this. This is your client. If it is requesting to the server, it will reach that server. It will check inside that server. Now database is what? You can call it as a data warehouse here. So client is what? Client is visiting superstore. He doesn't find a product which is trying to purchase. It will go back and check with the server. Server will check whether that product is available in the warehouse or the database. It will pull that information and it will revert it back to the client. So this way of processing the information is called as a three-tier architecture, or rather client-server architecture, right? So this is how the client-server architecture works. In real time also, I've shown you, if a person is trying to visit a superstore, if that specific product he's trying to purchase is not available, he will reach out to that store manager. Store manager will act like a server in the background DBMS. There is no person who is managing this. There would be a server which is managing. You have to interact with that server. Client is the one who is who is asking a question. So that server will respond whether it is yes or whether it is no. This is your three-tier client server architecture. We only have two tiers, client and server. Okay. Very good question. We have only two components, right? This is client and this is server. But how come we are calling it as a three-tier? There are only two components, right? How come we are calling it as a three-tier? See, whenever you're connecting with client and server, there is a way of communication, right? This way of communication, you can call it as a third component. This way of communication. Let me give you an idea. This is one. This is two. Ideally, client should be one. Ideally, client should be one because it starts from client. It never starts from server. Client is the one who is requesting. From this client, it goes to server. But how is it going? It is going through certain medium, right? There is a certain way of communication. That way of communication is called as a third component. Now, in this third component, there is an application.
The middleware, right?
Yeah, middleware, rather. There is an application server and there is an application client, which will act like a third component. Because communication is going from user to client, this application client to application server, and from that server, it will go back and fetch from the database or a database. So that middleware, that component, which is a way of communication in between, it will act like a third component. This is how it becomes three-tier architecture. Right? So we have seen how DBMS is managed, how that three-tier architecture works. Now, there is only one more last component which we have to manage, right? Inside this database, accepted. If you're working on any specific database, the information is stored in the tables, rows and columns. Now, there should be some relationship between these tables, right? How that relationship happens is, see, you visit a certain area. Now, this specific area belongs to all your food items. And inside this, there are multiple tables which are part. This is one table. This is one more table. Now, the question is, now, this is your you can call it as a cooking material or all your raw material area where all your food items are kept. This specific designated area, right? Now, if you're visiting this specific area, would you find any clothing component here? No. This specific area is designated for all your food. Anything related to food items would be kept here. You cannot find any component which is related to any electronic product, right? Electronic product is not your food product, right? It is not related to cooking. Maybe you will find some spices. Maybe you will find some raw materials, maybe your dals, pulses you're trying to purchase. You will find some packed items, right? Might be even your noodles or all this stuff is related to food. So you will find similar set of products which are designated to cooking. Now, how these products are managed? Because all these products are broadly classified into their subtypes. Now, if you're visiting that food area, food section or cooking area, all your food related products are only kept. Maybe you're visiting a space where all your electronic items are kept. Maybe you're visiting a space where all your clothing items are kept. Maybe you can keep clothing as well as footwear next to each other because that are all related to your fashion sense. So in database also, similar set of tables are managed or clubbed together. Now that similar set of tables, you can call it as a relational tables or relational database management system. There is a relation between the tables, right? You cannot keep a clothing item or a clothing rack between your food items, right? Which is very odd. I mean, how a person who is trying to purchase a food product will immediately change his mind and he'll try to purchase a clothing product, right? It is not right. So your product should be easily segregated. Similarly, in database, all your databases, all your tables should be easily segregated. But there should be relation between the tables which are kept next to each other. That relation is called as a relational database management system. There are many other database management systems. If I try to take an example, there is a hierarchical database, there is a network database, there is a relational database, and there is an object-oriented database. Forget about all three. Only focus on the relational database management system. What is relational? There is a relation between each tables or each racks which are kept next to each other. Similarly, in database, the tables which we are creating, there should be some relationship with these tables. How relationship is created, that is a different part. But there should be a relation. If you're creating 2 or 3 tables, I'm not saying every time a relation should be there, but usually the database management system which we are going to discuss and how we interact with this database, how we interact. We interact with a language called as SQL. SQL is your language. So whenever you are working in SQL, SQL is a language which supports interacting with relational database management system. There should be some relation between the tables which are kept next to each other. That relation we can manage with certain rules and regulations that we are going to discuss in further sessions. But how do we interact with the help of SQL, which is nothing but your language? So I'll take a pause. Any questions on this relational database management system explanation, or how do we interact with that?
Yeah, I have a question, sir.
Yep, go ahead, Nakul.
Question from the OLTP and OLAP. So, for example, as you mentioned over there that we have a OLAP and OLTP database in our SQL server or in SQL. Okay,
Mhm.
so there I have a question like how to identify these database in our SQL server.
How to identify, okay, I mean,
Uh, uh,
how many
uh,
databases are there? That is what your question is, right?
No, basically we have the databases in our server because we
Mhm.
have a multiple databases in our server. So how to
Mhm.
identify that is the OLTP and that is the OLAP database?
Okay, good. Now, see, keep one thing in mind. Whatever we are discussing, that is all related to OLTP because database is one which frequently updates. Now, how OLAP is different as compared to OLTP is, see, OLAP, you can call it as a high level of database, which is not a part of your database management system, but it is kept slightly different. It is slightly separated from the normal database management system. You can call data warehouse as OLAP. You can call data lake as OLAP. You can call data mart as OLAP. Now, what these three components are? I'll give you a very basic example now, right? Let me differentiate it now itself so that it is very easier to understand how we would manage all these databases and how different these terminologies are. See, whenever you are considering database, I mean, the example of database, let's consider an example of data lake first. There is a data lake here. Now, next to data lake, there should be always a data warehouse. See, you should follow this hierarchy. You should never change this. Now, after data warehouse, there is a data mart. And after data mart, at the last, there is a database, DB. I'll only keep it as DB. DB or DBMS, whatever, DB. Person who is managing this is called as DBMS. Now, what is the basic difference between all three components? Same. We were discussing about a retail product. Let's take any specific product. Now, I'll take an example of soap. How this soap is manufactured? This soap is manufactured by certain set of raw materials, right? You'll never get a soap directly, right? There are certain components which are mixed together, which are tightly coupled, and then that soap is manufactured. That soap is ideally available. So whenever you're manufacturing a soap, it goes through certain processes. First thing is all your raw materials should be combined together, right? All your raw materials should be combined together. So wherever all the raw materials and all your unmanaged data, I mean, whenever a soap is getting manufactured, raw materials are all clubbed together, right? A raw material can be anything. It might be a glycerin. I mean, there are many soap products, right? It might be a glycerin, some fatty acids. There are that are all combined together. Some essence are combined together, and that soap is manufactured. So there are multiple raw materials are kept. Information is not available directly. The soap is not available directly. So let's compare that soap with the information. Whenever you are working on any specific managed information, that information is not directly available. There are some raw materials, there are some raw information clubbed together to form a finished product. Similarly, if you take an example of raw material, data lake is your raw material factory. You can call it as a data lake, as a factory. Factories where all your raw materials are clubbed together, a finished product is manufactured. Now, whenever a soap is manufactured, it goes through certain processes, right? Again, it is not directly available in the shops. It is not directly available in the retail shops. So when the soap is manufactured, all these soaps are gathered together at a certain location that you can call it as a warehouse, right? Warehouse is where all your products, the manufactured products are kept first. So there are multiple soaps like this. So all these soaps are kept in a certain designated area. That area is called as a warehouse, and that warehouse you can call it as a data warehouse. Factory is your data lake. Warehouse where all your finished products are kept is called as data warehouse. And inside this warehouse, there is a certain rule which we follow, right? A soap is manufactured. A soap can be any soap, right? It might be a detergent soap, or it might be your daily use soap, right? Daily toilet soap. So all your detergent soaps are kept in one single area. All your toilet soaps are kept in one single area. Or maybe there are many other some soaps, maybe baby soaps, right? There are baby soaps as well, right? So all your baby soaps are kept in one single area. So this is called as one data mart. This is called as second data mart. This is called as third data mart. So data mart is a part of data warehouse only where all your products are segregated by their specific filter criteria. There is a specific filter criteria in a data warehouse, right? You never dump anything directly into the data warehouse. Data warehouse is a structured as well as semi-structured. You cannot call it as a unstructured. Whereas a data lake, it is unstructured because in factory, nothing is structured. All your raw materials are unstructured. They are coupled together. They are mixed together to find or to get the finished product, where that finished product goes through warehouse. Inside that warehouse, there are different I mean, filter conditions, right? That filter conditions, you can call it as a data mart. And from this data mart, a person is trying to purchase, maybe a retailer is visiting that data warehouse. He want to purchase all the detergent soaps. So this detergent soaps goes to the shop. Shop, you can call it as a database. So the example here, what it signifies is data lake is highly unstructured. Data warehouse is semi-structured. You cannot call it as a fully structured also, semi-structured, whereas a database is purely structured. Because if you visit any superstore, all that store's information is, I mean, it is all filtered, right? Nothing you can, it is very difficult, or maybe you will never feel any difficulty. You visit any superstore, you are trying to purchase a product, you visit that area, you can find that product easily. But if you visit a warehouse, warehouse is so large that you have to first check with the person who is managing that warehouse. And if you visit a factory, it is not even understandable, right? So data lake is at the highest level of hierarchy. Then comes data warehouse. Inside this data warehouse, only data marts are there. Data mart, in simple terms, you can call it as a combination of multiple components which are similar to each other. Detergent soaps, all detergent soaps belongs to one category. Your toilet soaps, all your toilet soaps belongs to one category. Your baby soaps, all your baby soaps belongs to one category. So similar set of products arranged together are called as data marts. So combination of multiple data marts form a data warehouse. And then from that data warehouse, the product goes to a shop, which you can call it as a database. Now, I assume that you might have got a basic idea. See, I'm not saying that you should be very pro with this example. Just to give you an idea, data lake is highly unstructured and at the highest level of hierarchy. From then it goes to data warehouse, which is not highly unstructured. You can call it as a semi-structured. From that data warehouse, it goes to a database. Inside that data warehouse only, there are multiple data marts.
Okay, so one more thing here, I just want to know if, for example, I go for the entity anywhere, if anybody asks me this
Yep.
question, okay, so
OLTP is your
how to make it
database.
simple? How to make it simple?
OLTP is your database.
Mhm.
OLTP is purely structured. The data which is getting frequently updated is called your OLTP. Data lake, data warehouse, data mart is anyways, data mart is a part of data warehouse. All these components, you can call it as a OLAP.
Okay,
Why
got
it
it.
is called as OLAP is the information in the factory, it is not getting frequently updated, right? Bulk number of products are manufactured. So in a factory, not every day a person will go and check whether the stock is there or not. In a bulk, they'll get all these components and then only they'll start the manufacturing. So why OLAP belongs to data lake, why OLAP belongs to data warehouses? See, transactional processing, we have seen an example. The data which is getting frequently updated is called as your transactional processing. Why OLAP is related to data lake and data warehouses? See, you visit a shop. Now, you purchase a product, that product is not available, that person will call the data warehouse or the wholesaler that this product is not available, give it to me. So that data warehouse person will again go back and share that product with that shop. Information is getting frequently updated. Whereas data warehouse person, what he will do, after every week, he will go back and check whether the stock is present or not. Shop owner will check on daily basis. Whereas data warehouse person, wholesaler will go back and check it on weekly basis. And if you go to the factory, that person will check on monthly basis whether our business is working fine or not after every monthly transaction. So information which is getting rarely updated. I'm not saying it will never update, it will update rarely. It is called as a historical information. What this wholesaler will do, they will check last 1 year of transaction history. They will check last 7 days of transaction history, whether our business is working fine or not. So similarly, even the factory people will go back and check the previous information, whether the product which we have manufactured, it is going through the market or not, it has a good market presence or not. So they are doing some analysis in the background. So that analysis, you can call it as a online analytical process. The database is updating frequently. There is, even in database analysis can be done, but the information gets updated very instantly. Within seconds it will update. That is called as online transactional processing.
Okay, got it. Like a live match is coming, and so the data is frequently changing. So it is called like a OLTP.
Yep.
Okay,
Anyways, you're
got it.
taken an example of match. If a person is trying to run between wickets, that one run you have to update it frequently, right? Very instant we have to update that in the scoreboard. That is called as OLTP. And
Okay,
how many runs that person has scored in the previous? What was his average? How do you analyze it? It is called as OLTP.
got it,
So
got it, got
is
it.
data mart structured or unstructured data?
Now, think whether it's a structured or unstructured.
It is a structured data, right?
Good.
Yeah,
Data mart
that's
is
what it is.
structured. Data mart is structured only, then the data warehouse, you can call it as a semi-structured, right? Even data warehouse is highly unstructured. But just because of multiple data marts which are clubbed together, you can call it as a semi-structured. Data mart is structured.
Okay.
Any other questions related to these 4 components?
So when you actually load a data, you initially load it. The sequence is first to data lake, then to data warehouse, data mart, and then to the database.
Yeah,
That's the flow of data.
Ideally how the flow happens is, see, if you're working on any real-time project, that real-time project information is coming from a certain website. Now, from a website, you will get lakhs of records, and that records are structured, unstructured, we are not sure. So that all records are dumped to a data lake. From data lake, there would be a data engineering team. All these processes comes under data engineering. From that data lake, data engineering team will, what they will do, they will, I mean, they might have got certain target, right? They might have got certain requests that this is what we want to process. Maybe they will go back to that data lake, get that highly unstructured information, do some transformation in between, make sure it is semi-structured. All similar set of products are arranged in separate data marts, and they are dumped to a data warehouse. From that data warehouse, if a data analyst wants to again clean that data, because even data warehouse data is not highly cleaned. So if you want it to be highly cleaned or purely structured, it's the data analyst role who will go back to the data warehouse, check whether the data is highly cleaned or not. If it is not clean, do some additional transformation and get it to a database or a storage account and dump there. We have seen the role of a Power BI, right? The Power BI person or a data analyst. Let me share that role also.
Okay. Would you be explaining what a data mesh is?
That is all related to data engineering. I'll explain it. Maybe if I explain it now, it will again confuse you. But in simple terms, how data mesh is. Data mesh is nothing but all your the spider like. I mean, you have seen the spider net, right? There would be a mesh. Mesh means it is nothing but all your points are connected to each other. May not be all are interrelated, but somewhere each and every point is somewhere connected to some other point. That point is connected. A is connected to B, B is connected to D, D is connected to E. Somewhere there is a mesh-like information. In simple terms, maybe I'll explain it in detail in further sessions if you want, but I'll not keep it very complex now.
Yeah. No, so when you say a data mesh, it is at a database, a data, at what level in this structure does a data mesh
It
come
is
in?
all in the data lake and above, not in database.
Okay. 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 Yeah. Fair enough. Thank you.
Okay. Just a moment. So we have seen the role of a data analyst, right? Now you see, somewhere the information is stored in the data warehouse, which you can call it as a semi-structured. Now anyways, we are discussing all these in detail. Let me also give you an idea about how much cost it takes to manage all these things, right? Costing is also important. Accept it. We are taking all these examples, but even costing plays an important role. If it is very highly costing, people will think, even organizations will think whether what to use. See, the big question is in OLAP, there is no relation. In OLTP, there is a relation. Because in OLTP database comes, under this database, there are tables, and every table is somewhere, it should be related to each other. That is why RDBMS comes here, Relational Database Management System. Whereas in case of OLAP, there is no relation. It can be anything. You dump any kind of data, there is no relation. You have to go back and check. Now, can you think out of all these four components, forget about data mart. Data mart is anyways part of data warehouse only. But out of all these four components, which component would be costlier? Is it a database or is it a data lake?
Either database, right?
Why?
Because there is storage and the database will be owned by some specific organization which will need the licensing cost.
Okay. I mean, why? Okay, you are somewhere near to the answer. But see, I'll simplify that answer for you. Maybe I'll give you a hint. How the hint happens is, so if there is a let's take a small example that this is now there are two different you can call it as a containers. This is container 1 and this is a container 2. And inside these containers, and there is a sale going on. Right? So you visit a superstore or something like that. There is a sale going on. This is out of what we are discussing, slightly different example. There is a sale going on and there are all the products which are kept. Some clothing products, all these clothing products are kept here. Some clothing products, right? Some clothing products are kept. Now, this container contains all your clothes in a arranged manner. Arranged means all your clothes are neatly folded and kept. This container, container 2, not arranged. I mean, the information is not arranged. Now, if you take the same example, if all the products are arranged and if the products are not arranged, which among these two containers would be more time consuming task? Which container will take more time to get available or get easily? I mean, if the all your clothes are dumped, maybe hundreds of clothes are there, it will take 15 to 20 minutes ideally to keep all that 100 clothes or 100 products in a highly arranged manner inside this container. Maybe it will take 15 minutes. But if all that products are dumped into a container 2 without any folding, without any arrangement, it will take only 5 minutes, right? It will only take 5 minutes. Now, with this same example, you are comparing data warehouse or data lake with database. Data lake is very, very fast. It's very fast. But the information is not arranged. It will take some time to extract the information from the data. It will take some time. Even though it's a fast, but if you're trying to fetch any information, you're trying to find a product from this container 2, you want to purchase a product, but that product is not easily available, right? You have to go back and check all these highly unmanaged or not arranged clothes. But it will take some time to fetch that information. Whereas if you visit this container 1, where whatever product you're trying to purchase, that product is highly arranged, right? So you will find it very easily as compared to this container 2. Now, retrieval time is faster here. It might take 1 minute. Here, not even 1 minute, it could be 1 second also. But in case of data lake, it will take 60 seconds or maybe 1 minute, right? It might take 60 seconds or here it might take only 1 second. But there is a difference. If a person is trying to remove any product or find any product from this arranged container, it is very easy to find. But while arranging, it will take some time. So while managing this container, it's an additional task. There might be a person who is folding all the clothes and keeping all that clothes in a certain container. Whereas there is no person required. He will dump, I mean, whomsoever is, giving this sale, he will dump all that products in the container too. So there is no additional person required here. So this component, arranged component, you can call it as a database. Why is it costlier? Is database is slightly costlier. Maybe you can call it as a highly costly also because it requires a person who needs to manage, who needs to update it frequently. Whereas a data lake can store bulk records. It can store bulk. If a database is storing 1 GB, data lake can store 100 GB or even 1 TB also. But the retrieval time is more as compared to database because in data lake or a data warehouse, the information is purely unstructured or maybe semi-structured. And there is no person who is managing this. If a person wants to fetch any information, he has to go back and check what all information is present, apply some transformation logic. Depending on the size of the data, depending on your logic, it will take some time to fetch that information and get back to you. Whereas a database, everything is highly coupled, highly arranged. Within few seconds, you will get the information, but there is a dedicated person who is doing all this for that dedicated person, it will take an additional cost. That is why database is slightly costlier. Data lake is bit cheaper. But in real terms, if 1 TB of data is stored in a data lake, this 1 TB will cost you somewhere around $1,000. Just an example. Whereas this 10 GB of data will cost you $500. This 10 GB of data will cost you $500. That's how costly the database is. So if 20 GB, it will cost 1,000. Whereas here in data lake or data warehouse, 1 TB of information we are managing within $1,000. That's how the differentiate happens, is because in database, there is a designated person. Everything has to be cleanly managed, arranged. Whereas in data lake, data warehouse, that is not clearly required. It is all your dumped data. And as I've said, it stores vast amount of data. So all your historical data is dumped into warehouse or data lake, and all your data which you are managing frequently, which is updating frequently, the current data, the current year data, or the data which you are keeping it frequently updated, that is called as a database. And it would be highly changeable data, and it is, I mean, it's very fast. Within seconds, it has to change. Within seconds, it has to retrieve that information. Right? So this was all about your data lake, data mart, data warehouse and database. Now again, coming back, we were in a relational database. What all relational database? There are multiple relational data. Relational database is nothing but your SQL. SQL is your language to communicate with the database. So that there are different languages which are available. In SQL also, there are sub languages, right? In every dialect. If you take an example of Hindi, as I've said, every state has a own way of pronouncing the Hindi. If you take an English, even Indian English is different. The US English is different. The European English is different. So that's how in SQL also there are different sub dialects. Like Microsoft SQL Server is one language. You cannot call it as a one language. You can call it as a one dialect. Words would be somewhere similar, but slightly change in pronunciation. So same goes with if you're comparing Microsoft SQL Server or if you're comparing MySQL, everything is SQL only. But there are few changes, few commands are different. So there are different types of SQL databases. SQL is your language, database is where you try to communicate with that SQL. So there are different sub dialects available in SQL. So everything is one part. Everything is only one SQL, but there are slight differences between all these different SQL languages, so sub dialects. Now, what we are going to learn, we are going to learn more about MySQL. Why? MySQL is free. MySQL is open source. Anyone can download, anyone can use it. That's the reason we're going with MySQL. Now, I'll not directly jump to MySQL, but prior going to MySQL, I already have this MySQL workbench. But prior going to this MySQL workbench, there are certain, steps which we need to follow. What all these steps are? So when you're trying to download this MySQL, right? So directly search MySQL downloads. Go to this, in the Google, you will get this. Go to this. You have an option, right? MySQL. See, there is an enterprise edition also. I would not recommend to download all this enterprise edition. Come back. Yeah, there is this community edition. Enterprise edition is costly. It is a paid version where moreover, you can call it as a paid version. Go with community edition. Click on this MySQL community edition. You have this option, download MySQL community edition. Now, if you click on download now, see, it will open a different page. So this is all the information you will get. Now you have to select which OS is present in your laptop or desktop. Go with Windows. You will download this 771 MB file. Maybe there is a zip file also. You can download this zip file as well. Or else there is one more method. This is the latest method. This is the latest method. The one more method is mention MySQL Workbench download. The very first option. This is how it would be visible. Now this is just an installer. Once you install this, 42 MB is just an installer, right? Once you install this, there would be some 700 MB file. You have to, once this 42 MB file is downloaded, you have to install that. Within that installer only, you will find some 700, 800 MB installation process. Now, what that process is, how you need to follow that steps. See, steps are very easy. I'll share that document with you. Maybe if you're following our KSR recordings also from our website, you have created your login. There you will find MySQL installation steps. Let me share that document as well. This is the ideal document. Let me go to slideshow. MySQL download for Windows. You will find this download MySQL installer. This is how it will look. You can download. The next step is once you click on download, it will ask you to log in. Need not log in. Go with the no thanks, just start my download. Login is not required. It is not required. Once you click on this, some file would be getting downloaded here, right? So once you've done that, once you have installed, once you have downloaded that file, double click on it, it will start installing. This is the main step at which you have to choose the right method. Maybe this is older version. In the new version, you will get server client full. Maybe there is no custom. Always select an option which is full or complete. You will find full or complete. Either of the words would be there. Install full. Never only install server, never only install client. You should be installing full. So select this full. Automatically, these are 6 different components or 7 different components which would be installed in the background, which would be all arranged in the background with that MySQL. It would have server, it would have client, it would have all the router, that is middleware. Everything would be present here. So once you click on execute, now there is no next option. This is execute. Execute means it will start installing all these sub components. Once everything is done, see, this is how it will look. Percentage, how many percentage, what is the progress of each and every product. So all once it is done, you will get complete. Next. Now, this is again one more important condition. Need not change anything inside this networking window. Check whether your port is 3306 only or not. If it is 3306, let it be as it is. Click on next. Here you have to mention your SQL password. And what is your SQL username? Username is admin. Username is admin. Default for MySQL Workbench, username is admin. You have to mention a password. Remember this password every time you log in this MySQL Workbench. Once you download it, it will ask you to log in with your username and password. Username is admin. Password is what you mention while installing. And you are the sole owner, so need not add any user. If this workbench is shared with some other person, you can add that user. You're not sharing, right? You yourself are using it. So need not add any role. Only mention the password, click on next. Everything should be next. Next. Yes, grant full access. Now, this is how it would look like. Once everything is done, the installation would be done. You have to click on finish. Done. Here, username, it is asking it as a root. Either you go with admin or either you will go with root. Now, why admin and root are somewhere similar is, see, you are the sole person who is managing this MySQL Workbench. That is the reason admin is called as a root here. Root means you are the root of this complete SQL installation. You have full authority. So you mention admin or you mention username root and mention the password which you have mentioned while installing. It will log in. Now, once you log in, how it would look like? Say I've opened my MySQL Workbench. This is my root. It will ask you for the password every time. So I have to mention this password. So it will open this MySQL Workbench. This is how MySQL Workbench would look to you. Right. So I already have multiple tabs. I mean, For my end, I do have the tabs, but it doesn't mean that you should also be able to see all these tabs. No, that is not the case. For you, it would be very fresh. You will have only few default schemas which are available here. You will have Sakila, you will have Sys, you will have World. That's it. Forget about the other above 4 or 5 schemas or databases which I've created. So this is the exact UI of MySQL Workbench. Already this installation steps are shared with the recordings. Try to check. And anyways, I've said it's very easy to install, nothing difficult. So once you install, open that, mention your root, mention your username, which is root, mention your password. Once you log in, this is the UI. Once you log in, you will get some information page. Delete that information page. I mean, some window you will get, you can close that window, right? So whenever you click on any window, next to that, there is this cross icon. So you can close that window. And towards leftmost corner, there is a plus SQL icon available. If you click on this, a new window will open where you can write your queries. You can write your own queries. Now, as we have discussed all your database management system, what is relational database? How do we interact with the help of SQL? We have discussed all about this. Let's start with the very basic. Now, basic is whenever you're creating a database, your schema will come into picture. Physical schema, logical schema. Why? Because physical schema is what to create and how, where to create. Whereas logical schema, whatever you are creating, how and what all components should be present in that. What is logical and what is physical, we have discussed, right? Where to create, I mean, the place where to create your database, or logical is what, how we want to create, what should be the components present in that. So there is a schema option towards left, right? Schema is nothing but you can call it as a database only. It's a part and parcel of database. But there are two different schemas, physical schema and logical schema. Now, physical is what, how a database is created. Logical is what, inside the database, what all components should be present. So that we need to come into picture. Now, as I've said, if you want to interact with the database, there is a language called as SQL. That SQL follows certain rules, which is nothing but your commands. So we need to write that command. Now, in commands also, there are subtypes. The big question is, in every component, there are subtypes. How do I remember all these components? For that reason only, I am explaining it with a very easy example, which is your superstore. You should know your superstore example. Whenever you're working on database, keep your mind ideal, keep your mind in a stable mode, and always take an example of superstore. That superstore is your database. Inside that, there are different racks, which are called as tables. How that rack structure should be, how that database structure should be is what your physical, and what all components should be present, rows, columns, it is your logical schema. So take that example, keep that example in mind, and all that racks should be similar to each other in some areas, designated areas. That is called as relational database. So keep this example in mind whenever you're working in database for a few, maybe for next 1 week. If you keep this example, you will get used to it. So once you get used to this terminologies, the database terminologies, then it is very easy to write your queries, easy to interact with your database also with the help of SQL programming language. Now, schemas, you have to first decide what should be your database name. So I need to create a database first. I need to create a database. Create database. Now, what does this language mean? I'll explain it. But I'm trying to create a database. That means I'm trying to create a schema, physical schema first. Create database. Now, our batch is going to start from March. So March batch. This is my database name. This is my physical schema name, rather. And whenever you're writing a query, you have to pass that query, right? Client server architecture. You are the client. You are writing query. You have to pass that query. It should go to the server and it should interact. So how it is interacting? In order to run this, you need to run this, right? You need to execute this. Whenever you want to execute anything, there is this thunder icon which is available. Execute. executed, one row affected. Now, what does this one row affected mean? I have created a database. That means I have created a schema, physical schema. Physical schema is the name of that schema, right? The name of the schema is March batch. So where is that March batch? You have to refresh it. See, once I click on refresh, March batch database or March batch schema is created. Done. Now, once the schema is created, I need to use this schema only. That means I need to use this database. Inside this database, what table should be, how many tables it should have, how many records or columns it should have. So all that I have to decide. So in order to use that database, you need to use a command called as use database. And I want to use this database, right? So you have to click on this and close this. Now, there is some error in this language, or there is some error in this command. I'll run this command first. I'll run this. Say I've selected. Say I need not run everything. Already I've run this create database. That means I've already created this schema. I have to only run this. So I have to only select this and click on execute. Now there is this error. What is that error? See, if I remove this, that error is gone. There is some error. That error is gone. Now if I run this, 0 rows affected. That means you have created a schema. You are inside that schema. That means you have created a database. You are inside that database. And whatever you are going to do now, everything would be under that database. First thing is you have to always create a database. Inside that database, whatever you want to do, you have to do it inside that database. So first, database creation is called as physical schema. And once that physical schema is created, inside that database, how a table should look like, how a view should look like. Along with tables, there are views, there are stored procedures, there are functions, there are many other components which are part and parcel of, there are indexes, there are common table expressions, there are subqueries. These are all part of your database. These are all part of your SQL programming language. So we are going through all these components. We'll go through that. But if you want to create all these components, it should be created inside your physical schema, which is nothing but how to create is what your logical schema is. This is your physical schema. And once you are inside physical schema, how to create a table, how to create a view, how many columns should be there, how many rows should be there, that is your logical schema. Right. Now, the big question is, in the first query, I have mentioned create, I have mentioned database, and I have mentioned the name of the database or name of that schema. But in the second query, why, if I use database, if I mention this database command, why is it giving error? Because in SQL, if you're interacting with any database with the help of SQL language, there are certain rules and regulations. So you need to follow that rules and regulations. So what all that rules are? I'll only start with basics first. What is that basic? There are 3 different, or rather 4 different languages present inside that SQL, or you can call it as a 4 different subcomponents present inside that SQL. That subcomponents are data definition language, data manipulation language, data control language, and data query language. Along with this, 4 to 5 subcomponents are present. We will discuss all this. Now, I'll only start with the very first component, which is called as DDL. What is this? This is called as data definition language. Now, what is DDL? What it is, why it is called as data definition language. So I want to create a database. I want to create my database. So first thing is you have to define what should be the database name. Without name, you cannot create, right? You should first define. Once you define it, only then you can use it. And inside that database, you can write whatever you want. So whenever you are creating some component in SQL, it might be database or it might be table inside the database also, you need to define. So you are defining something, how a structure should look like. That is called as data definition language. You are defining something, right? Even you are using that database. This is also called as data definition language. Why? Because you are defining that I want to use this database. I want to use it. I have defined that this is the database which I have created. I want to use it. This is also called as data definition language. You're defining something. You are giving a command that I want to define the structure of the database. This is the name, and it should look like this. That is called as data definition language. Now, as I've said, inside database only, there has to be a table present. Now, how to create a table? Create what I want to create. I want to create a database. No, already a database is there. I'm inside the database. I want to create a table. So it should be create table. Now, what should be the table name? ABC. I'm just taking an example. Create table ABC. Now, how a table structure should be? Rows and columns you need to define, right? How a table structure should be. You need to define that. So how do you define how a table is created? Right. So we have created a database, which is already done. Inside that this database, I want to create a table. So how a table structure should be? Table structure should be like this. Right. This is your table. Now inside a table, you need to define how many rows and how many columns are there. Now the big question is, do you think rows are defined while creating a table? Do you think the rows are defined while creating a table? No. Rows are part of a table, but rows are not defined while creating a table. Columns are also part of a table, but columns are defined while creating a table. Whenever you are creating any specific table, rows are not defined. Rows are dumped into it, but columns are defined. Columns are defined first. Once you define your column, once you create your table, then you can dump all the data with the help of row format. So whenever you're creating a table, first you have to define a column. Now, what is the column? This is column 1, this is column 2, this is column 3. Inside every column, there is a row, right? One row, second row, third row, fourth row. So you cannot, you cannot define rows while creating a table, but once the table is created, you have to define the rows afterwards. So whenever you are creating a table, I'll go back to the query, create table. I want to create a component table. I've given it a name. Now you have to define the columns. Column 1. Now, whenever you're defining a column, there is the most important component. What should be the data type of that column? Now, what is data type? If you visit a store, you're trying to visit a rack, or maybe you are managing that store. You want to manage that specific area where all the food items are kept. Now, if all that food items are kept, you need to filter, right? This rack will contain all the processed food. This rack will contain all the raw materials. This rack will contain all your liquid food. So you are defining. Similarly, whenever you are creating a table, whatever columns you are creating, you should define a data type to it. So this column 1 will have data type called as char. So there is a data type called as char. Now, what is char? What is varchar? We will discuss again in the further session, but just to give you an idea how a table is created, I've defined a char. I'll come down, I'll create one more column. I don't want only one column in my table. I've created one more column called as char. And this char will contain 60. And maybe I want to create one more column, which is, and inside this column, the data type is int. Int is nothing but your integer. Integer is nothing but your number data type. So this is my table. Now, if I run this query, a table is created. Now, how do I find a table is created? If you refresh this, see, earlier table didn't have any drop down. Now you can see a table is created with ABC name, table ABC name, and inside that ABC, there are 3 different columns. Column 1, column 2, column 3. So you are giving a command that I want to define a table. That table should have these many columns. You are defining something, right? You are defining something. That is called as data definition language. You are giving it a command that this is how the structure of a table, this is how a structure of a database should look like. Database, first you have to create a database and then you have to create a table. Now, if you want to insert some records, maybe you want to dump some records inside this table ABC. I want to dump some records. Dump. You need not create a table. Table is already created. But inside that created table, I want to dump some records. So insert into. Now what is table? Insert into table, accepted. But what should be the table name? Rather than mentioning table, it should be table name here. It should be table name here. So I'll copy this ABC, insert into ABC. Now, what I want to insert? I want to insert values. Insert into ABC values. I want to insert some records. Maybe I want to insert 1. Maybe I want to insert Ritesh. Maybe I want to insert some other value. Maybe I'll insert my age. Right, I'm inserting. Right, so I want to insert these records. So, and whenever you write any specific SQL command, always close it with a semicolon. So I want to insert. Insert means I want to dump that record inside a already created structure, which is called as a table. So whenever you are dumping any data, you need not mention that where you want to dump. You want to dump inside this ABC. But what is this ABC? This ABC is a table. We have already defined it. So whenever you are inserting into ABC, ABC will default assume it as a table only. So it is not recommended to mention insert into table. Rather, it is insert into that table name. And if I run this query, it will throw an error. What is this unknown column Ritesh in the field list? So there is one important concept you have to understand. Whenever you are dumping any data as a character data, that character data should be in semicolons. 1, 2. Now if I run this query, you see one row affected. That means that value is inserted inside the table. Now I want to search. There is a value already present in the table, but I want to search what all values are there. How to search? You need to first select that table. Select what you want to select. I want to select all the columns. So rather than mentioning one column, column 1, column 2, column 3, maybe I'll mention that. I want to select column 1. I want to select column 2. I want to select column 3. From which table I want to select from ABC. So if I run this, you see there is a record inserted with how come 289? I would have, okay, my bad. But anyways, so if you see here, I've inserted 3 record. I mean one row in it. This is one row. There are 3 columns, but this is one row. Rows are never defined while creating a table. Only columns are defined. Rows are defined once the table is created. Once you dump some data, that is how a row is defined. So one dump, one record is called as a one row. Right now, the question is, you will have a question that whenever you are inserting any character data, a string data, string is what? A word. It should be mentioned in double inverted commas or maybe single inverted commas. Even if you insert it in double invert, it will still work. Now the question is, even this one is also character, right? Even this one is also character. Okay, C2, I have mentioned Ritesh, which is character, but even this one is also character. Keep one thing in mind. One, you might feel the data type is character, but one is a numeric value. So if you want to insert numeric value in character also, if you want to insert numeric value in integer also, you need not mention any inverted commas. It is not required. Only if you want to dump any string data, a word data, a character data, in that case, it should be in inverted commas. Now, the big question, if you want to define something, it is called as definition language. Once you have defined, you want to dump some information in that, it is called as manipulation language. You are manipulating the data. That means you are inserting, you can insert also, you can update also, you can delete also. You can do anything. Now, if we have only inserted it, maybe you want to delete, you can delete it. So all that insert, delete, you are managing that information inside that already created structure, already defined structure. So wherever you are defining a structure, it is called as definition language. Once that structure is defined, you are managing the data inside that defined structure. It is called as manipulation language. It is called as manipulation language. And in DML, you can call it as a subtype. If you want to check what all records are present inside that defined structure, it is called as data query language, which is select. Now we'll go through all these components, but just whatever you want to define is called as definition language. Once the definition is done, once the structure is created, you are managing the information inside that structure is called as data manipulation language. It's called as data manipulation language. And you want to check what information is inserted, what information, how the table is created. That is called as data query language. Data query language contains only one command, which is select command. Only one command. DQL, data query language, only one command is present in that. In data definition, create is one command. We have only seen create. In data manipulation, insert is one command because we have only seen insert. There are many other commands, but every command belongs to subcategory, which are DDL, DML, DQL. There is also DCL. We will discuss all these, and there is also TCL. L belongs to language, D belongs to data. Now, M, D, between the, I mean, these between words. D is definition, M is manipulation, Q is query, C is control. Here, T is transactional control. Now, we will discuss all these, but just we have started with what is DDL. DDL means definition. We are defining something. So in order to define something, you have to pass a command, which is create command, and see the difference of the query. Whenever you are defining something, what you want to define? You want to define database. You want to define table. So you have to pass that component name also. But once this component is defined, whenever you want to dump any information to that component, you already have given a name to that component. So it is not required to mention insert into table values. It is always insert into table name directly. Why? Because ABC is a table. We already know. The database already knows ABC is a table because we already defined it. So whenever you are manipulating any data, it is not required to mention that component name. See, I haven't mentioned table. Whereas while creating that component, you should mention what should be that component. It's a table, it's a database, it's a view, whatever you want to create, you should mention that component. But once you want to insert any information inside that component, it is not required because already ABC is a table only. The database will automatically assume that ABC is a table. So it will insert that records into table. Right. So this is all about basics. We have only started with basics, very basics. Now, going further, I mean, as I've said, our pace was very slow until today for first 3 sessions. Maybe the pace will slightly increase from session 4 and session 5. That means from tomorrow onwards, the pace will slightly increase because we have already discussed all these components. Now, I want you people to go back and understand what all these components are. Understand this, then jump to the query. Directly, if you're jumping to SQL, again, I'll reiterate, never learn SQL without knowing background of it. You should know all these backgrounds, which we have discussed today. All this. One is relational database also. One maybe I'll keep it as relational DBMS. Right? So this is how it should look like. SQL installation steps. Again, as I've said, if you have logged into our KSR Data Vision website, please log into our website from wherever you are checking the recordings, right? If you're trying to check any recordings. So how you're checking that recordings, you sign in, you click on sign in. Right? So once you sign in, you will go to the courses. So you might have already enrolled for the free sessions, first 5 free sessions, this one. So once you enroll for this, you will get the recordings, right? Class records. Left side, you will get all the files. There, SQL installation steps are already mentioned. SQL installation steps are already mentioned. So you need not worry, that steps are already available. Download that PDF. Now, it's anyways 9:28. Again, the one who have only joined with today's session, I'll reiterate. This course is for data analytics with full stack Power BI, where we are going to start with SQL. Anyways, we have already started it. Along with SQL, we are going to cover Power BI. We are going to cover Azure services, moreover, Azure Data Factory and its dependent services, along with basics of Databricks, Synapse, and Logic Apps, which is more a kind of advanced engineering. So this is what we are going to cover in this course. A long 4-month duration course. This is the ideal, the complete duration of this course. So 4 months, Monday to Friday morning sessions, 8 to 9:30 a.m. The same time we follow. Just because it's a free sessions, we are extending it till 9:30. Usually I close it by 9:15 only. So that last 15 minutes are of buffer time where you can ask your questions, where we can have some discussion. 70 to 75 minutes of session, you can assume. 4 months, we started with March first week, assuming that we should close by July first week. It should be June end, but July first week, I'll assume July first week itself. 4 months, 1 month for SQL, 2 months for Power BI, and 1 month for all your Azure services. So 1 plus 2, 3 plus 1, 4. 4 months, 22 sessions of SQL would be there minimum. I'm talking about minimum. There can be more than that. Minimum 38 sessions for Power BI. I'm talking about minimum. It can be more than that. Somewhere around 40 also. And again, 22 sessions for Azure. So that's how the course structure is. 4 months. Regarding fees, as I've said, it is 30K if you pay it in 3 different installments. I'm talking about installments, 10, 10, 10. It is 28K if you pay it in 2 different installments, 14, 14. And if you pay it one time, it is 27K. K is your thousands. So one time is 27K. 2 times or 2 MIs is 14, 14K. And 3 MIs is 10, 10K. We would be giving Power BI premium per user license, which will cost you $20 per user per month. So if you convert it into Indian rupees, somewhere 80, 8 to the. Now the question is, are we only spending 20 rupees? It is per month. So 8 to the 16. 1600 plus 1600 for 2 months, it is 3200. So we are giving you a 3200 Indian rupees license. This is all about your course. I'm open for questions. Any questions in related to course or maybe related to session which I've covered today?
So the next session is going to start tomorrow. How is it?
Yeah, tomorrow. Today is Monday, tomorrow is Tuesday. Monday to Friday daily sessions, not on weekends. We had a weekend that's
And so I missed the first session. So where can I find the information about the first session?
Again, as I've said, you need to log into our website to check the recordings. That is one way. Second way is
So we need to create a login. I mean, how do
yeah, you can log in with your Gmail. What your personal email is, what you have, you can create your login there. Right? If you click on login or if you click on sign up, it will ask you to sign up. So you can mention your email ID, all that. Now, the other ways, if you visit our KSR YouTube channel, the day 2 session is not yet uploaded to the YouTube. Yeah, if you visit this. How come this opened? So if you visit our YouTube channel, even in our YouTube channel, if you go to videos, the first session is already uploaded. Second session would be uploaded by maybe next half an hour. Even today is the third session. Even third session would be uploaded here. So you can check. This is day one. This is day one, session one. You will get session two and session three also by end of today. Session two would be anyways available now itself. Session three by this session would be anyways available by end of the day. But for installation, you have to always log into our website because that is where the PDF is kept. That installation PDF is kept. So
where is the PDF? I don't see any PDF.
Okay, have you logged in?
No, not yet.
So once you log in, that is where you will find. Once you click on sign up, login. Anyone who has already logged in?
Yeah.
Okay, Vasu. Let me stop sharing. Vasu, can you please share your screen?
Yeah, sure.
Yeah, I'll show it from your end because mine is an instructor login, so it is slightly different.
One second, I'm sharing.
Yeah, sure. See, once you click on share, you should click on screen, complete screen, and then click on share.
Sure.
So
the payment of the
two ways.
How do we make the payments?
Either you make from a website. I'm not saying that you should make a payment by today. You have still 2 more sessions.
Can you view my screen?
Yes. So how to make a payment either by website from paid sessions, or there would be a call given from KSR team also, or else you can pay it from the website. Or you can connect with our team. You can call them. They'll share you the details how to make the payment. 2 ways, either by website. From website also, you're facing any issues, you can always call. But I would always suggest while making any payment, try to connect with our team. They'll definitely help you out.
Sure.
Now, once you log in, see, this is how sessions or class records would be available. Today's third, it is still live, so it would be available post 30 minutes. Towards left. See, in the contents. So this is how all the information is kept. Scroll down. Click on SQL components below. Yeah. So this is MySQL.
Okay.
Yeah. Click on that. Click. You haven't clicked, it seems. No, not on the PPT. Click on that name. Yeah. Is it?
Actually,
Right.
I follow the instructions, but I'm facing some issues with the installation.
No, installation. Now the big question is, one who have already installed the MySQL workbench, if you have already installed it somewhere back, first uninstall it, clean that. Only
Okay.
then you will be able to install it. Do not install it again and again. First clean the existing system, uninstall it, then again reinstall it.
Okay.
Yeah, towards left, see, as I've said, towards left in the below, you will get the SQL installation steps.
Yes.
If you click on this, you should be able to get an option here. Download PPT. I'm not sure why are you not getting it.
So,
No, not there. If you click on that component only, you will get an option.
okay, I will check it out. Thank you very much. Can I stop sharing?
Yeah, you can. Anyways, I've stopped from my end.
Yes.
Okay, any other questions related to this course? Yeah.
I have a question. I was actually part of November batch for Power BI. So I wanted to attend live SQL sessions. So I'm attending now. So I do not see SQL sessions records in my queue.
Okay, and good. Rajni, great. I remember you. See that 5 free sessions. I would request you to go to the free sessions, that option, courses, free sessions. Enroll for that 5 free sessions. You will be able to see all that 5 sessions. Post, you will be directly added with the paid sessions. You have already part of Power BI and Azure, so you would be automatically added to a batch where all the sessions would be visible, including first 5 and paid sessions also. So for the first 5, you have to enroll for that free session.
Okay. I'll try that.
Now,
Thank you.
any other questions? And see, if you're planning to learn Power BI, go ahead.
Yeah. Do you have any data bank for questions? I mean, if you are preparing for
okay, so whatever I'm teaching,
certifications after this.
Yeah, certifications, that dumps all that, everything would be given from our end. You can do practice also.
Okay.
From the certification point of view, see, I would always say it's target certification once your Power BI is done, once you have a good hands-on experience. I would not say that once the SQL session or Power BI sessions are done, directly go with certifications. Will take some time to adapt that change. Now, questions, data sets, everything would be shared. That is a different part. Along with whatever technical skills we are going to cover, the SQL Power BI, in between, I'll highlight what can be the interview question. I will anyway share the interview questions, but I would always request whenever I'm practically explaining something, every practical session, maybe I'll give you some hints that this can be an interview question. Even today, I've given you hints, right? Related to DBMS, related to relational database, related to how DML, DDL works. For a fresher, you should know what is DDL, DML. And I'll highlight one thing, which I felt is not up to the mark from the candidate point of view is a person with 3 years or 4 years of experience also, it is very difficult for that person if I mention or if I ask him to write a create command, he will forget that command. So keep a habit. You should never forget a command in SQL, which is a basic command. I mean, if you're forgetting a complex logics, you should know what is logic, how that logic works. If you forget the query, it's okay. But if you're forgetting very basic queries also, it is very difficult to survive in this industry. So you should know basic about SQL very crystal clear. So that's the reason the pace at which we are covering, you should understand that pace. And again, I've said directly do not jump to the queries. First understand the background, then jump to the queries. And one more thing, if you are planning to join with Power BI, join this session, join with SQL. Best is because all the SQL components which we are going to cover, you will find many similarities with respect to Power BI. In Power BI, there are many components which are somewhere similar to SQL components. I'm talking about logic. I'm not talking about query. If you write a query here, that doesn't mean you should write a query in Power BI. I'm talking about logics. So keep a target, start with SQL, because if you start with SQL, it is very easy to understand Power BI and then move to the Azure. Now, again, open for questions.
So tomorrow's session is going to be on the SQL or
SQL only. First 23 sessions would be on SQL. We would close SQL and then jump to the Power.
Okay, so it is kind of mandatory to listen to the first session before I start on the next tomorrow's SQL session.
First session you can leave it. Maybe the session which we had on Thursday, it was more a kind of demo. I would request you to start from Friday, because Friday is where we discussed about the components of database. Friday, today's session, if you go with, that's okay. You can easily understand. Any other questions? Okay, if there are no questions, I guess we are good on time, almost 12 minutes more than that. Thank you, everyone. I hope that I was able to answer all your queries. If you have still any questions, you can note it down and you can reach out to me in tomorrow's session or maybe our KSR team. They'll help you out. Yep. Thank you, everyone. Have a very good day. Let's connect back to me.
Thank you.